Hi everyone. Today we are going to study distributed systems in system analysis and design. A distributed system is one in which the data, process and interface component of information system are distributed to multiple locations in a computer network. So see, basically for any information system, you need to have a network of computers, right? So whatever information is being shared, it is shared through a computer network. And when we talk of a distributed system, then in that distributed system, as the name itself says, everything is distributed across multiple locations in the computer network. That means we do not keep everything at just one location, but we distribute it across multiple locations in the network. So a distributed system is one in which all the components, that is your data, the process of transforming that data into information, the interface component. Interface component is that component that lets the end users interact with the system. So the data, the process and interface component of which system? Of the information system are distributed across multiple locations in the computer network. Accordingly, the processing workload required to support these components is also distributed. So when all the components are distributed, so is the processing workload also distributed. So basically the processing workload is required to support these components, because at the end the processing of all these components would yield the end result. So the processing workload is also not just concentrated at one location, but the processing workload also, like the components, is distributed across multiple computers or multiple locations on the network. When I say multiple locations, that means basically multiple computers. In this system, each processor has its own local memory. So there are several processors. We are not just relying upon a single processor to do the processing task. There are multiple processors which are distributed across multiple locations or multiple computers. And each of these processors has its own local memory. The processors communicate with one another through various communication lines. Now, since the workload is distributed among several processors, so each processor is doing its own processing task, but the end result will be provided when all the work done by all the processors is integrated together. That means the processors need to communicate with each other so that they can integrate all their processing work. So for that the processors communicate. And how do they communicate? The processors communicate with one another through various communication lines. And what are those communication lines? Such as high buses or telephone lines. The processors in a distributed system may vary in size and function. Now, since there are different processors distributed across multiple locations in the network, there is no such compulsion that all these processors will be of same size. The processors may vary in size and they may also vary in their functionality. So the processors in a distributed system may vary in size and function. The implementation of a distributed system is complicated and difficult, but still it is in demand. See, obviously when the components are distributed among several locations, the processors are distributed among several locations, and then all the processing done by so many different processors has to be integrated together. This is not an easy task. This is a complex task. So obviously for that reason, the implementation of a distributed system is complicated and difficult, but still it is in demand. Now, why it is in demand? Some of the reasons are that the modern businesses are already distributed. So the modern businesses work on the distributed system model. These businesses are already distributed, hence they demand a distributed system. as I said, so they demand distributed solutions. In general, solutions developed using a distributed system paradigm are user friendlier. So one reason is that all the businesses are already distributed, so they demand distributed solutions. Hence, for that we need distributed systems. Another reason is that the solutions that are developed using a distributed system paradigm are much more user friendlier, and more the user friendlier any system is, the more easier it is to use it. Now let's look at the advantages of distributed systems. The advantages of distributed systems are, first of all, resource sharing. Since everything is distributed, including the components and processors, so there is a sharing of resources, which is always a good thing, because the resources are not just occupied by one system, they are shared among several systems. Then there is computation speed up. Obviously, as I said, there are more than one processors, there are multiple processors which are distributed across multiple locations, so obviously the computation speed up is there, right? Then there is reliability, because the components are distributed, the processes are distributed, so we are not solely reliable upon just one location. We know our components and our processes are distributed among several locations on the network, so even if at one location things fail, the other location is always there to provide you with a backup. Then there is communication. There are high-end communication buses, there are telephone lines, so communication is easier using a distributed system. So these are the advantages of a distributed system. Now let's look at the architecture of a distributed system. Basically, the architecture of the distributed system is known as consists of the 5 layers. So what are the 5 layers of a distributed system architecture? The first layer is, among the 5 layers, the first layer of the distributed system architecture is the presentation layer. So the presentation layer is the actual user interface. This is the layer which is providing the interface or communication between the end user and the system. This is the presentation layer, which is actually presenting the information to the end users. The second layer is the presentation logic layer. The presentation logic layer includes processing which is required to establish user interface. Now, before you establish user interface, you need to do the processing work. See, what are you doing in the user interface? You are providing a communication between the end user and the system. Now, how is this communication provided? With the help of information. Whatever information you have to provide to the end user is provided through the user interface. But before you can actually establish a user interface, you need to process that data to convert it into information. So you cannot establish user interface without information. What communication will you provide if you have nothing to communicate? You need some information to present it to the end user. Only then the user interface will come into use. So this presentation logic layer basically includes the processing which is required to convert the data into information, so that after that you can establish the user interface and communicate that information to the end user. So what are the examples of a presentation logic layer? What kind of processing does it include? Which the examples are editing input data. Whatever input data you have provided, that is edited and then presented after proper formatting and editing. Formatting output data, whatever output data is there, it is formatted in a proper format. So these are all examples of the processing done by the presentation logic layer. The third layer is application logic layer. The application logic layer includes the logic and processing required to support the actual business application and rules. So as the name itself suggests, application logic layer. So this layer basically includes all the logic that is required, the logical and the computation required and the processing required, which is required to support the actual business. So logic and processing required to support the actual business is provided by the application logic layer. Example is the calculations. Example of the tasks done by the application logic layer includes the calculations that are required. Next is your data manipulation layer. The fourth layer is your data manipulation layer. The data manipulation layer includes all the commands and logics required to store and retrieve data to and from the database. See, once the data has been processed and converted into information, it needs to be stored somewhere so that it can be accessed from that place. Also, when you need to feed some information into the system, you need to have some mechanism of putting it into the system. So this place from where the data is accessed and data is stored is basically known as the database. So you need some mechanism to store the data into the database and fetch the data from the database. So this is provided by the data manipulation layer. This functionality of storing the data into database or accessing the data or fetching the data from the database is provided by the data manipulation layer. So it includes all the commands and logics. Whatever commands and logics are required to store and to retrieve or access the data to the database and from the database is done by the data manipulation layer. Now the last and the fifth layer of the distributed system architecture is the data layer. The data layer is the actual stored data in the database. So what is this layer? The actual stored data, the data which is actually stored in the database is your data layer.